This lesson is from section 6.3. The exercises begin on page 448. There's a lot of material in this section, but we're only going to be dealing with one specific part, and that is the part on solving exponential equations. That's going to be our focus out of this section. Before we can begin that, we need to talk about a special number called E. E is like pi in that it is an irrational number. It's a decimal number that never ever ends, and it has a constant value. It can be approximated by this expression, 1 plus 1 over n to the nth power, and then in calculus we take the limit of that, and that gives us a value for E. It is named for Euler. I know his name starts with an E, but it's pronounced Euler, and that's why we use an E, is because he's the one that found it. It does appear naturally in natural phenomenon, and it's very important in the working calculus. Here's a decimal approximation for it right here and right here. I'm on page 443 in your book if you've lost me. Here shows you what happens to this expression as the values of n get very large, and you can see that it's approximating the value of E. What you need to know is that we will use it as a constant, and I'll give you more information about it as it comes along. But that's what it is. It's a number like pi that we use in expressions, and it occurs in exponential functions and logarithms will be the next topic after this one. So I wanted to mention that. Now, I sent you a handout, and the top part of that handout is what goes with this section. So you'll want to refer to these 3 steps. We're going to be solving exponential equations, and the rules are to rewrite each side of the equation as a power of the same base, that is, make the bases the same. Then use the law of exponents, that if a to the x equals a to the y, then x equals y, and then solve the resulting equation. There's more on that paper, but that's for later section. This is the part we're going to be focusing on in this section. So now I'm ready to begin with the problems that are on page 448. And we're going to begin with problem number 65. And we have 6 to the x equals 6 to the 5th. Well, the first requirement is that the bases have to be the same, and you can see here they're already the same. And when the bases are the same, you make the exponents equal, so x equals 5, and you're through. You finish solving that equation. Let's go to number 67. 2 to the negative x equals 16. Well, here you can see the bases are not the same, so we need to rewrite one or both sides so that they will be the same. And I recognize 16 is 2 to the 4th power. So that doesn't affect this side of the equation in any way, because all I did was make a substitution for here, that instead of 16 I wrote 2 to the 4th. Now that the bases are the same, we can make the exponents equal, and if it doesn't come out in x equals like over here, then we need to finish it. In this case, we need to multiply both sides by -1, and I get x equals -4 as my answer. Number 69 has 1/5 to the x equals 1 over 25. Now, what might be helpful in this problem there are two options. We can make the base 1/5, or we can make the base 5. We're going to start with the 1/5 option first. I know that since 25 is 5 squared, 1 over 25 is 1/5 to the second power. So that makes x equal 2, because those bases are the same. Okay? Now, that's the easiest way to do that problem. But if you didn't think of that, you remember when we studied exponents, we said that a to the negative n is 1 over a to the n. So 1 over 5 is 5 to the negative 1. 1/5 is 5 to the negative 1. And I raise that to the x. And 1 over 5 to the second is 5 to the negative 2. And you remember in the laws of exponents that when we raise a power to a power, we multiply the exponents. Now the bases are the same, they're 5, so I can make the exponents equal, multiply both by -1, and I get the same answer. My point is, there's sometimes more than one way to do a problem, especially if there are fractions involved. But this is probably the easiest, but some of you might not have thought of doing that as 1/5 as a power. Alright, so now we're moving on to number 71, that has 3 to the 2x minus 5 equals 9. Well, my bases are not the same, so I need to make them the same by making a substitution. So I'm going to change 9 to 3 squared because it's equal to that. Now I can make my exponents equal, so 2x minus 5 equals 2, and I do whatever I need to solve that equation. So I'm going to add 5 and divide by 2. And that's my answer for that one. Then we go to number 73. And it has 3 to the x third equals 9 to the x. So again, I want my common base to be a 3. So I'm going to change this 9 to 3 squared, and then I have to keep it to the x. Like I said earlier, when you raise a power to a power, you multiply the exponents. So now I'm going to make the exponents equal, and x cubed equals 2x. Well, when you have a power higher than 1, you're probably going to solve it by factoring, and to do that, one side has to be 0. So I'm going to subtract the 2x to make this side 0. Then I'll look for a common factor. And then use the zero product property that says set each factor equal to 0. So I make x equals 0, and I make x squared minus 2 equals 0. Well, this one's solved, but this one I have to add 2 and take the square root. And remember, when you take the square root in an equation, you get plus and minus. That's what caused some of you to miss a problem on the midterm, is you forgot that when you take a square root, you get plus and minus for the answer. So this problem has 3 answers: 0, the square root of 2, and negative square root of 2. Number 75. Now, you want to be careful here. You've got to write both sides as powers. Now, it's true that 16 is 8 times 2, but 16 is not a power of 8. So we have to find a common power, which is 2. So I'm going to change this 8 to 2 to the third and keep the exponent like it was. I'm going to change this 16 to 2 to the fourth and keep its exponent. Now I use the rule that a power to a power, I multiply the exponents. Now I'm going to use the rule that if the bases are the same, I can make the exponents equal. I'm going to add 3x over here. And then I'm going to divide both sides by 11. And I get that answer. Alright, now number 77. Alright, my common base can be 3 because I can change this 27 to 3 cubed. So part of the challenge for some of you in this work is going to be recognizing powers of numbers, recognizing that 27 is 3 to the cube, 3 to the third. So what you might want to do is make a list of the numbers from like 1 to 6 and write out what their powers are, first, second, third, fourth power, so that you can recognize powers of numbers and know what kind of substitutions you can make. So I'm going to multiply this 3 times this 2x. Now that the bases are the same, I'm going to make my exponents equal. This is a quadratic equation, so I need to solve by factoring. So I'm going to subtract this 6x, and I'm going to put it in the middle so that my terms are lined up correctly for factoring. So I need two numbers that I can multiply to get a negative 7 and add to get a negative 6. So that would be a negative 7 and a positive 1. Their product is negative 7 and their sum is negative 6. So when I factor, I use minus 7 and plus 1. Then I set each factor equal to 0 and add 7 and subtract 1. So my two answers for this one are 7 and negative 1. Alright, number 79, I've got 4, 2, and 16, so my common base will be 2. So I'm going to change this 4 to 2 squared. I'm going to leave this 2, and I'm going to change this 16 to 2 to the 4th. So that step was just making the bases the same. Now I'm going to do some simplifying. Raising a power to a power, you multiply. So I'm going to multiply here as well. Now, one of the rules of exponents says that when you multiply powers, see right here I'm multiplying, you add the exponents. So to multiply these two together, I need to add 2x plus x squared. And now I finally have 2 to a power equals 2 to a power. So I can make the exponents equal. And I'm going to need to solve by factoring. So I'm going to, whoops, you can't see that. I'm going to subtract the 8, and I'm going to put the terms in the right order. So I'm going to write the x squared first, then the 2x, and then the 8 that I'm subtracting. And I factor, and the two numbers that I can multiply to get a negative 8 and add them to get a positive 2 are a positive 4 and a negative 2. That product is negative 8 and that sum is 2. So I'm going to do x plus 4 and x minus 2. Then you set each one equal to 0 and subtract the 4 and add the 2. So I get negative 4 and positive 2 for the answer to that problem. Alright, on number 81, we're introduced to the e that I mentioned at the beginning. So we just treat it like a constant, like it was a number. It is not a variable, it is a constant. So e to a power equals e to a power means I can make the exponents equal. I'm going to subtract the 5x, and then I'm going to divide by the negative 3. So there's my answer. So x equals negative 4. So you work it just like if it was a 7 or a 10 or whatever. It just happens to be an e. Alright, so this is an E. I miscopied that. That was an E right there. This is number 83. So I think the first thing I'm going to do is to work on this one. Because of that rule that I mentioned earlier, this rule right here, 1 over E squared is equal to E to the negative 2. I'm using this rule going in this direction. So 1 over E squared equals E to the negative 2. So that's what I'm going to do right here, is to make that substitution. Like that. Now I'm multiplying powers, and like I just said, when you multiply powers, you add the exponents. So that's going to be 3x plus a negative 2. So now I have e to a power equals e to a power. So I can make the exponents equal. Again, to factor, because it's quadratic, one side's got to be 0. So I'm going to subtract the 3x and add the 2 to get all these terms over on the left side so that I can factor it. And the two numbers that I can multiply to get a positive 2 and add to get a negative 3 are negative 2 and negative 1. The product of those is positive 2. The sum of those is negative 3. So I'll do x minus 2 and x minus 1. Then I set each one equal to 0. Add 2, add 2. add 1, and I get 2 and 1 for my answers for that one. Alright, the last one in this group is number 85. It says if we know that 4x equals 7, then what can we say about 4 to the negative 2x? Well, how can I make this look something like that? You remember that you raise powers to powers, you multiply. So get a negative 2 times x, I must have raised 4x to the negative 2 power, because that would be negative 2 times x would give me negative 2x. Okay? Well, the top line tells me that 4 to the x, is equal to 7. So if 4 to the x is equal to 7, then this becomes 7 to the negative 2. And using that same rule again about negative exponents, 7 to the negative 2 is 1 over 7 to the positive 2, which is 1 over 49. And that would be the answer to that one. That's the only part that we're doing in this section 6.3, solving these exponential equations. So you're ready to do those exercises now.